So we've used these before. We've played with trig identities before. And the early parts of what we're doing is really similar to stuff that we've already done. As we move on into it, we're going to talk about simplifying trig identities and stuff like that. But this is really just an expansion of things that we have already done. And we are working in section 5. I'm going to hate that. 5.1 in the book. And basically, we're just going to be starting to use these trig identities a little bit more. I really am only focusing on one part today. One, because I know it's our first day back and I wanted to keep the lesson relatively short. And to kind of remind you, like, this is the stuff that we have been dealing with. And if you remember, the identities are things that kind of are equal to each other, right? We've got our reciprocal identities, which really are our 6 basic trig functions and where they come from, right? We know that sine is the inverse of cosecant, 1 over cosecant. Cosine is the inverse of secant. Notice this side is just the opposite of this side. And those are really important trig identities right there because they're going to be the ones you use the most. I would say the next ones would be the Pythagorean identities, will help you out a lot. And then you have your even and odd identities you won't use nearly as much. Cofunction a little bit, but the quotient identities you'll use quite a bit. So you'll use these a ton, right? You'll use these a ton. And you will use these a ton. The others, they'll come up, but they won't be nearly as common as those first 3 groups. And we've played in these before, so it shouldn't be anything too new to you. And the whole idea is that we're going to be using these identities to evaluate trigonometric functions. And today we're just going to start a little bit using the identities to evaluate functions. When I see you later, we'll talk about simplifying trig functions and factoring them, and then doing things like adding and subtracting and all of that, doing operations on them. But for today, we're just going to do some evaluating. So it would help if I wasn't going to try and write with my eraser. So what we're going to start with is we are going to evaluate using, oh man, I already hate this. There's a lag when I write. Using trig identities. So if I am given so for example, given the conditions secant of u, right? That's just the name of our thing, equals -3/2. And tangent is greater than 0. We want to find all 6 trig functions, right? What are the 6 trig functions? They are sine, cos, right? We've got sine, cosine, tangent, cosecant, secant, and cotangent, right? So we want to find the values of all of those based on the information that we're given, right? And right now, the information that we're given is that secant of u equals -3/2, and that tangent is greater than 0. Now, the first thing I would look at when I saw something that had secant is to try and figure out what cosine is, right? So I know based on these reciprocal identities that cosine is 1 over secant, right? So I know that cosine of u is going to be equal to 1 over secant of u, right? I know that. And so I know what secant of u is. So I know that this is equal to 1 over -3/2, right? And if I want to know what 1 over -3/2 is, I'm just going to take that 1 and I'm going to multiply it by the reciprocal of this fraction, which is -2/3. And I am going to get -2/3. So what do I know now? What information do I have now? I know that cosine of u equals -2/3, right? I know that secant of u equals -3/2, right? So I only have 4 more to find, and they're going to start getting easier. But there's some things that will make it a little bit better for me in figuring it out. And one of those things is remembering the signs of sine and cosine and tangent based on the quadrants, right? In quadrant 1, we know that sine is positive because y is positive. We know that cosine is positive because the x is positive. And we know that tangent is positive, right? In quadrant 2, we know that sine, which is y, would still be positive. Cosine, which is x, would be negative. And since tangent is sine over cosine, tangent would be negative. And I know we've done all this before, but I also know we've been off for a week. So I want you to just kind of get this little refresher. Here, sine and cosine, x and y, are both negative. So I would have sine is negative, cosine is negative. Tangent is sine over cosine. Negative over negative is a positive. Here, sine is y is negative in this one. Cosine is x, and x is positive over here. And here, tangent is sine over cosine, negative over positive is a negative. And the reason I tell you this, the reason I'm explaining this to you, is because in the beginning, we were given 2 pieces of information, right? We were told that secant of u equals -3/2. And from that, we found that cosine of u equals -2/3. Well, that is negative, right? We know that cosine is -2/3. We know that tangent is positive. So we have to go, well, where is cosine negative and tangent positive, right? Well, that would be right here in quadrant 3. Why is this important? Because we know that anything that's related to sine now is also going to be negative. So sine would be negative, cosecant would be negative, cosine would be negative, and secant would be negative. But tangent and cotangent are going to be positive. What we've learned is it's in quadrant 3. Why is that important? Other than for the signs that you need to put on each of these trig identities, it's not, right? Everything's going to solve the same way. It's just we know what sign to give each section based on what quadrant it lies in, right? And we know what quadrant it lies in because we're given this parameter. So we have cosine and we have secant, right? So what do we need? We need sine of u. We need tangent of u. We need cosecant of u. And we need cotangent of u, right? We need to find the rest of these. Now, how we're going to do that is by using these trig identities right here, right? The first thing is I know what cosine is, and I can find sine because I know what cosine is using our Pythagorean identity. I know that sine squared of u plus cosine squared of u equals 1, right? So I'm going to go ahead and subtract cosine squared of u from both sides, minus cosine squared of u, so I know what sine squared equals. And I'm going to get sine squared of u equals 1 minus cosine squared of u. Well, what is 1? That would be 1 minus negative 2/3 squared, right? Because cosine is negative 2/3, and we know that it's squared. So that means that sine squared of u equals 1 minus 4/9. Negative 2 squared is 4. 3 squared is 9. So we've got minus 4/9 because this minus is on the outside, even though it became positive on the inside. We still have that on the outside. If we look at this, we go, okay, well, that's 9/9, right? Because that's the same as 1 minus 4/9 equals 5/9. So we know that sine squared of u equals 5/9. So sine of u is going to equal the square root of 5/9, which is the square root of 5 over 3. So we know this is the square root of 5 over 3. Is it positive or is it negative? Well, it would be negative, right? Because we know that sine in quadrant 3 is negative, right? Doing an ugly job of this. I promise, I will get used to this new whiteboard, but right now it is the bane of my existence. And so now we know 3 of the 6, right? Well, I know that cosecant of u is just the inverse, right? It's 1 over sine of u, which just means we would flip it over. So cosecant of u would just be equal to negative 3 over the square root of 5. But I can't write it like that because I can't have that radical on the bottom. So I would multiply this times rad 5 over rad 5 to rationalize the denominator. And I would get equals negative 3 rad 5 over 5. And so we're done there. Now we just have to deal with tangent and cotangent. Well, if I look at tangent, what do we know about tangent is that tangent, let's see, we can see it down here. Tangent equals sine over cosine, right? Which means that tangent is equal to negative 2/3 over negative rad 5 over 3. And I'm going to come over here and do the math on that just because I don't have a lot of room up there. But if I do this, it's going to be negative 2/3 times the reciprocal, right? Because that's how we multiply divided fractions we solve divided fractions by multiplying by the reciprocal of the denominator, which is going to be negative 3 over radical 5, right? 3's are going to cancel, and we're going to get 2 over rad 5, which we can't leave like that. So we're going to multiply rad 5 over rad 5, and we're going to get 2 radical 5 over 5. That is our tangent, 2 radical 5 over 5. Notice that we multiplied a negative times a negative, so it became positive. But that makes sense for us because we know that our tangent is positive over here. Cotangent, if you remember, is just 1 over tangent, or we could write it as the reciprocal, which is 5 over 2 rad 5, which again, I cannot leave like that, right? And so I'm just going to multiply this times rad 5 over rad 5, and I would get 5 radical 5 over 2 times 5, and these would cancel, and I would have radical 5 over 2. And I know this looks really messy right now, because I wanted to show you all of the pieces, and I do have another example of it. But does that kind of follow? We're just finding all 6 of these trig functions based on whatever information that we're given. Does it make a little sense to you? What are our solutions? Our solutions are this bit right here, right? We found all 6 of our trig functions. Do you follow that? Does anybody follow that? Did I put you all to sleep? I know it's the first day back after a break. Is anybody still awake? Jasmine gets it. This is all you're going to be doing today in your assignment for today. I do have another example. If you want to see it, I can do it. If not, we can skip it. But it's really all going to follow this same process. Everything that you're doing today is going to be finding the identities. You don't have to memorize them, Jasmine. You can keep the thing in front of you. I will post this picture on PowerSchool so that you can have them in front of you when you're doing it. It does help to memorize it. You'll start memorizing them the more you use them. But in the meantime, have them in front of you. I will make sure that this gets posted to PowerSchool so you have access to it when you're doing it. But it's also in your book, right, on page 348, if that helps. But that's all you're doing today. I made sure all of your problems were just like this. You're going to use the different identities to find the 6 trigonometric functions. I'm not going to do this whole next problem unless you guys really want me to. I mean, I'm happy to do it if you want me to. I need a different color pen, though. I cannot work in red. It just makes me feel like I'm punishing you. The next sample problem I have is if we were given tangent of x, tangent x equals 1/3, and cosine of x is less than 0. Right? And if we look at that, we can go, okay, well, what do I know? I know tangent is positive because it equals 1/3. And I know that cosine is less than 0. So that means I, again, am going to probably be here Oops. Dang you. I'm probably still going to be in quadrant 3 again, right? Because I'm going to have a positive tangent, but I have a negative cosine. And the only place that I have a negative cosine and a positive tangent is in quadrant 3. So what does that tell me? It tells me that anything relating to sine is going to be positive. So sine would be positive, cosecant would be positive, tangent's positive, so we know that tangent is positive and that cotangent would be positive. But we know that cosine is less than 0, so cosine is negative, which would mean that secant is also negative, right? Because it's an inverse. And so when you go to solve those problems, you have that piece of information already, right? And you can solve each of those trig functions the same way. Now we're looking at this and we know what tangent is, right? And we know that tangent is sine over cosine. So I could look at this right off and say, well, if tangent is sine over cosine, right? Sine would be 1, cosine would be 3, right? Does that make some sense? If tangent equals sine over cosine and I have a fraction, right? I go, okay, well, tangent of x equals sine of x over cosine of x. How do I know that? Well, I've got this trig identity right here. I know that tangent is 1/3, which means that sine of x is 1, right? Sine of x would equal 1. Cosine of x would equal 3, right? And so you can use that and fill in all of your blanks. This one's actually a pretty easy problem just because tangent is already a fraction. So we know what sine is. We know, I mean, we can figure these out pretty easily, right? We know sine, we know cosine. Cosine would be -3, right? Because we know that it's negative. What do we know about tangent? Tangent was already given to us. Tangent of x is 1/3. Sine of, this is cosecant of x, right? What do we know about cosecant? It's 1 over sine. Well, that's 1 over 1, right? Cosecant is 1 over sine, and we know that sine is 1, so that's going to be 1 over 1, which just equals 1. Secant is 1 over cosine. Secant of x equals 1 over cosine, right? Which is going to be 1 over -3, which is just -1/3. Cotangent of x is the reciprocal of tangent, right? It's 1 over tangent, which just flips this over, and that would be 3, right? 1 over 3, if I flipped it over, would be 3 over 1, which just equals 3. This one was nice and easy for us, wasn't it? So that's all you're going to be doing. That is the entire assignment, is figuring out these trig identities. When I see you on Thursday, we're going to talk about simplifying trigonomic expressions. We're going to, I feel like I turned an extra page in my book. I did. I skipped a whole page. I don't know why it's doing. My fingers aren't working. We're going to simplify, we're going to factor, and we're going to be doing some solving. But for today, we are done. So try and get that done sooner rather than later so you have a little practice before going into the next part. But other than that, I have nothing for you unless you have questions, in which case I'm more than happy to stick around and answer them.